Yeah, so this is the one. Now again, it altogether it looks like garbage, specifically because first you got fractions in two, you got two separate fractions in parentheses, and then you got some negative exponents, which most fractions by themselves have destroyed lives, but negatives also have destroyed many lives. So negatives and fractions, it's like, holy crap, we don't even have a chance. We do. You just got to focus on one of these at a time. So, yeah, the question comes up, what is the operation between these two parentheses? You can't see it. It's the only operation that can't be seen, and that would be multiplication. If you ever do not see an operation, it's multiplication. Just like there's multiplication between the 2 and the x to the power of 3, you can't see it, which means it has to be multiplication. If it's ever subtraction, addition, or division, it has to be shown, has to be. Now, along those lines, well, remember to split this up into separate problems, right? So here's what I mean by that. Let's get rid of that multiply because it's gonna. So here's what I'm talking about, right? Let's take this, the first set of parentheses, and just see, can we simplify this? Now I'm talking about right now also ignoring the 4. Okay, so just ignore that exponent of 4. Can I simplify anything on the inside? I don't see that I can. Right, the 2 and 5, I can't simplify those. There's no other x's to simplify the x to the power of 3. There's no other y's to simplify the y to the power of 7. So it just kind of stays there. But now that I have that, I know that let's actually focus on the 4. And then this will give me a new fraction that I'm going to put right here. Okay, so again, evaluate it separately. Don't worry about that second fraction to the power of -1. Don't worry about it. We'll get there. I'm not saying don't do it. We'll do it. We just got to wait. Now with this though, I'm doing this in a specific order. You don't have to do it in this specific order. There's actually many different things students would do. In fact, some students with enough experience would be like, I can get rid of this -1 by simply flipping this fraction right here, and then they can work from there. That's fine. If you feel like you're comfortable doing that, do it. So I'm taking a specific route. You do not have to take this specific route to get to the end result. The goal is to get the end result. That's what we want, right? So on this one, my exponents of 2 and 5 are 1s. And again, this fraction is simplified, so I know after I apply the 4, and by apply I mean multiply, I will have a simplified fraction still, okay? So from here, I've got the 4 times 1, that's 2 to the power of 4. And then I've got x to the power of 3 times 4, which is a new exponent of 12. Now that's my numerators, but it applies also to the denominator. So I've got 5 to the power of 1 times 4, which is 4. And then y to the power of 7 times 4, which is 28. Okay, so this is my, that's my first fraction. Okay, so I said I was going to put it there. Let's do it. Oh, you know what? Let's take that back. Let's evaluate that. So I do have my x to the power of 12. That's good. And I've got my y to the power of 28. That's good. But I also have 2 to the power of 4, which is 2, 4, 8, 16. And then 5 to the power of 4, 225. Thank you. I was only off by 4 hundredths. So, yeah, thank you. There we go. Make sure you use a calculator when you put that in, all right? Remember, use the caret button. It's one button to the left of 7, one button up, for those of you that weren't here for that. Now, that's that. That's that. What I have here is just that first part, right? Let's take the second part here. Drop it down. And once again, let's just focus. Let's not worry about that -1 exponent. We'll come back to it, just not right now, right? So again, we look on the inside there. Is there anything we can do on the inside of this parentheses? Well, I see some stuff. Now again, is this the same stuff that you would do? I don't know. That's something you have to decide, but I do see that 2 to the power of 3, 2 times 2 is 4, times 2 is 8. So 2 to the power of 3 is 8. That's my 2 to the power of 3. Then I've also got my denominator, 5 to the power of 2. 5 times 5 is 25, right? So that's just evaluating those. I see the y to the power of 2 on the bottom. And again, the order that you do this may be different, but I'm looking at the y's. just because I was looking at the 25, but y to the power of 2, nothing else I can do with that y. But this x to the power of negative 4, I can reverse that into the denominator and then change the sign of the exponent. So now it's x to the power of 4, but on the bottom, right? Okay, with that, now we can look at the exponent, which was negative 1. So, if you understand that this just flips the fraction, that's great. But I'm going to assume that you don't, so that means we're going to have to do kind of like what we did up here, just apply this exponent to all of the exponents of the bases that are currently there. So I've got an 8 to the power of 1, which I need to see, and then 25 to the power of 1. Let's get that negative 1 multiplied by all the exponents. Okay, so this will produce a new fraction, and that's going to be 8 to the power of negative, 1 times negative 1 is negative 1. 25 to the power of 1 times negative 1 is negative 1. X to the power of 4 times negative 1 is negative 4. And y to the power of 2 times negative 1 is negative 2. Now the problem here with this fraction that I have is that all of the exponents are negative, which means if they're in the denominator, they now need to be in the numerator. And if they're in the numerator, they now need to be in the denominator. So 8 to the power of negative 1 will be 8 to the power of 1 in the denominator. I just don't really need that exponent now. 25 to the power of negative 1 moves to the numerator, which makes that exponent positive. Again, I don't really need a phantom 1 there. And then x to the power of 4, negative 4, goes to the numerator, which makes it positive 4. And y to the power of y to the power of negative 2 becomes y to the power of positive 2, because, again, I flipped it, okay? So this fraction now is the second fraction that was being multiplied there. So multiplied by my orange fraction, I got 8 in the denominator, 25, x to the power of 4, y to the power of 2. Now, what we're looking at this point, and just in case it's confusing, you can kind of get rid of this garbage. I want to see all the work, so I'm going to show it, but this is fraction multiplication, you guys. So look for anything that can be cross-simplified if it can. If it can't, then don't worry about it. But for example, what I'm looking at right now is the 25 and 625 are both divisible by 25. And that would be 625 divided by 25 is 25. 25 divided by 25 is 1. And then also the 16 and 8, they're both divisible by 8. 16 divided by 8 is 2. 8 divided by 8 is 1. And then in addition to that, well, let's just get that down for now, right? Let's focus on these one at a time. So in my numerator, just with the bases that are numbers, 2 times 1 in the numerator is 2. And in the denominator, 25 times 1 is 25. Now that's just the numbers. Now let's focus, let's look at the x's. Okay, so I got x to the power of 12 and then x to the power of 4. Both of these are in the numerator. So that means my new x base will have the power of 12 plus 4, which is 16. Okay, because again, those would be multiplied, those two x bases. And then I can look at my y bases. Now my y bases, I've got a y to the power of 2 in the numerator, and then I've got a y to the power of 28 in the denominator, right? So some students would just say these two cancel out 2 of these, so you end up with y to the power of 26 on the bottom. Let's show some work on that though. So here, yeah, that's good. That'd be y to the power of 2 minus 28, which would be y to the power of negative 26. Since it's a negative exponent, I'm going to put it in the bottom, in the denominator, but that would make the exponent positive there. So I suppose I am skipping a little bit of work there. Hopefully that's okay. But that's our final answer. Now again, this path that I took through all this stuff, you may have taken a different path. You may have chosen to apply different rules at different times. Again, none of that really matters as long as you get the same answer there.